Hello everyone. So welcome to this geometrical isomerism synopsis. So geometrical isomerism means which having same molecular formula, same structural formula, different geometry. So let's start all types of geometrical isomerism. So here we can see compounds having same molecular formula, same structural formula, but different geometry in a space across restricted system is called GI, geometrical isomer. Geometrical isomers are di-stereomer, means they are non-superimposable, not mirror image. So like here, that restricted rotation and that different geometry, you can see that here P and Q is different, here R and S is different. This could be same, this could be same, or this could be same, but one side this should not be same. Now here let's suppose in between distance is X, and now CH3, one CH3 is here, one CH3 is here, in between distance is Y. X and Y is not equal, hence it is geometrical isomer. So condition for geometrical isomer is that compound must have restricted rotation, terminal must be in plane. Terminal means this must be in plane, this must be in plane. P should not be equal to Q, and R should not be equal to S. So first system we will discuss, which will show GI, that is carbon double bond carbon. So carbon double bond carbon, in this you can see that first one, that here if we'll take this one, so in this restricted rotation is there, it is planar also sp2, but here that P and Q, hydrogen hydrogen, so it is not. So coming to next geometrical, that this double bond system, so here we can see that yes, hydrogen, and along with that this, and this side also hydrogen, and along with this. So P and Q not equal, R and S not equal, hence it will show GI. Next coming here that again this double bond will not show, and triple bond never show GI. Now coming to this system, so again here restricted rotation, along with this here P and Q is same, here also R and S is also same, so it will not show GI. So this one won't show GI, whereas this one will show GI. Similarly here this one is also not showing GI. Next, moving further, coming to this question, so here you can see that restricted rotation, along with that P and Q is not same, R and S is not same, so yes, GI. Similarly with restricted rotation, here it might look same, that P and Q is same, R and S is same, but if suppose we are considering this one, so this one can show GI. Similarly this one also can show GI, this one also can show GI, this one also can show GI, means now this one also can show GI. How? Like let's suppose if it is cis, so that time it will be trans, this will be cis, so this will be trans. So now this one also can show GI. So total how many geometrical centers? 5, including this 4, 1 this one also. Coming to this, you can see here that restricted rotation, and along with this it look like same, but when we will do its numbering, here at 3 oxygen is coming, but here it is at 2. So this P and Q not same, R and S not same, yes, GI. Next coming to second system, carbon double bond nitrogen. So again it having restricted rotation, in that P and Q should not be equal, and of course here R and lone pair is not same, so only one side we have to see, P and Q should not be equal, so it will show GI. So in that first case, let's suppose this is aldehyde and this is oxime, so both combining together, so water came out and it formed aldoxide. So in that restricted rotation there, here lone pair and OH, so R and S is different. Here you can see hydrogen and CH3 both different, yes, GI. It's naming or IUPAC naming, in that you can see that if OH is OH and H is same side, then it is syn. And if it is OH and H is opposite side, then it is called NT. Similarly, coming to after aldooxane, ketoxane. So like here it is, you can see ketone system combining with oxime, so forming ketoxane. So in that OH is in same side of CH3. So while writing name, it will be syn methyl phenyl ketoxane. No need to write NT-phenyl because by default it will be NT. If CH3 is same side of OH, so syn methyl phenyl ketoxane or anti-phenyl methyl ketoxane. Next, third system, nitrogen double bond nitrogen. Here no need to check because here by default P and Q will be different, and here R and S will be different, means P and lone pair different, Q and lone pair will be different. So no need to check, just nitrogen double bond nitrogen will show always GI. Coming to cycloalkene. So cycloalkene, that till cycloheptene GI will not show across carbon double bond carbon. Why? Because that it can show cis but trans not possible. From cyclooctane, from 8 member, now across double bond it will show GI, and here you can see this hydrogen is in same side, so it is cis. Now here this 8 member ring is twisted, so by twisting what happened, a strain came, so that's why here cis is more stable than trans. But yes, from 8 member onwards it will show GI. So 8 to 11 cyclooctane to cycloundecane, that it will show across double bond GI, but in that cis is more stable than trans. After 11 means 12 onwards, trans will be as usual more stable than cis. So trans will be more stable than cis. Now coming to across cycloalkane, across against here single bond. So you can see this one is restricted rotation. This one P and Q is not same, and R and S is not same. So yes, GI. Coming to this example, so in this we can see that here this rotation can happen. This is not a restricted line, like it can rotate like conformer, so no GI. But here we can see that this line is restricted rotation, means it cannot rotate. Across this, here hydrogen and this P and Q not same, and R and S is not same, yes, GI. Similarly here we can see across here that P and Q is different, R and S is different, so across cycloalkane it will show GI. Similarly here, now this is cycloalkene, so cycloalkene only have here valency 1, so only 1 is there, P is there but Q is not there. Here R is there, S is not there, so no GI. Similarly here also across this, so this carbon is sp2, so it can have only 1. This side it could be different, means here this one is also there and hydrogen is also here, might be possible, means hydrogen is also there. So this side it is okay, but this side it is only 1 P is there, Q is not there, so no GI. Now here you can see this is cycloalkene, but across double bond it will not show GI because till 7 member it will not show GI. 8 to 11 cis will be more stable than trans, and 12 onwards as usual trans is more stable than cis. But in cycloalkene, if that GI is, if we are seeing through that single bond restricted rotation, then yes, it will show GI. So whenever you are seeing that cycloalkene, see across single bond also, if double bond is not possible. So here across single bond, here you can see methyl group and hydrogen, here also methyl hydrogen, PQ, RS different, so it is yes, GI. Coming to here cycloalkene, so here it looks like same only with respect to this restricted rotation. Here this is same, here this is same, or with respect to this restricted rotation, here it is same, here it is same, or with this also looks same. So with respect to this it will not show GI, but here we can say that, we can see here that with respect to this cycloalkene, here hydrogen and methyl, and here that this one as well as, means with respect to this hydrogen and this complete system. So this will show GI, this one also will show GI. Similarly, here with in that cycloalkane, here restricted rotation there. With respect to this, here hydrogen and methyl, here lone pair and hydrogen. So yes, GI. Similarly, that similar type of questions we can see here, that here restricted rotation there, here methyl is there and hydrogen is there, here lone pair and hydrogen is there, but this lone pair is getting delocalized. So here P and Q, in that Q is not a fix, as Q is getting delocalized, so it will not show GI. So that lone pair, delocalized lone pair, will be not considered in the condition of showing GI. Now here in this, again this alkene system will not show GI because here this is same. So with respect to this restricted rotation, this cycloalkane, in that this one is restricted rotation, with respect to this, here methyl and this system is there, and here also methyl and this system is there. Or we can say that here it is methyl along with that hydrogen, here also methyl and along with hydrogen. So yes, GI. Now coming to cumene, or it is also called alene. So conjugated diene system is called cumene or alene system. So if it is even number of consecutive double bond, so it will not show GI. Why? Because yes, it is restricted rotation. Yes, P and Q is not same, R and S is not same, but it should be in plane, means PQ and RS must be in plane. So here we can see that this double bond which is formed, let's suppose here carbon Py and Py, pure orbital, forming pi bond. So now this carbon already Py is utilized, so it will have either Px or Pz. Means this, if it will be Px or Pz, means due to that this Rs will be perpendicular, means it will not show GI. So whenever even number of pi bond system is there, it cannot show GI, but odd number can show GI. Like here you can see, if here it is Py is utilized, so next its carbon Px will be utilized, so due to that it will be perpendicular. Next after that, this carbon now again can utilize its Py. So due to that, A and B and this side A and B will be in same plane. Like here we can see in this, like here this is in plane, PQ, and this is, let's suppose, Py. So next is Px or Pz. So next Py possible. So due to that it can come in plane. So always odd number of pi bond can show GI, but even number cannot show GI. So here this is odd number, yes, GI. Here it is, this is conjugated diene system and it is odd, yes, GI. Here we can see that even number, but along with that sulfur is third period element. So third period onwards, all those elements having lone pair also. So due to presence of lone pair, we can consider odd also this one. So here hydrogen and CH3, PQ is different, and here this double bond, along with that it having lone pair. So this one also can show GI. Next coming to aspiro. So aspiro means one common carbon will be there, homocyclic ring will be there. So even number of rings will show no GI and odd will show GI, because we know that one double bond having degree of unsaturation 1. Similarly here we can come to that one ring also having degree of unsaturation 1. So if degree of unsaturation 1 means this we can convert as a double bond, here also double bond. So conjugated diene system, if it is even it will not show GI, and if it is odd it will show GI. So similarly here also, that if it is even it will not show GI, if it is odd it will show GI, because it will be in plane. So now here we can see this, that here this and this even number, no GI. Here odd, so with respect to this it will show GI, because PQ and RS will be in plane. Similarly with respect to this, nitrogen having lone pair and hydrogen, and here this, so yes, GI. Similarly if it is even number, so even number cannot show GI. So with respect to this and here this, now it will not show GI, because this, if it is in plane, XY plane, so this will be in YZ or ZX plane. So according to this not possible. So now coming to here, if we'll take this instead of 4, if we'll take this 3, so with respect to 3, this system is in plane, and here this one is also in plane. At least this one is in plane. So as this one is in plane, in that we can see that here R and S is not same. So R and S is not same. So yes, GI. Once again, from here to here as we will take, so it is even. So here PQ and RS will be perpendicular. So it will not show GI. But if we'll take odd, so here as we are taking odd, so with respect to this, here R and S is different. So yes, it will show GI because PQ and RS are in plane. Similarly here again even, so it will not show GI. So we'll take again odd, means this one ring cycloalkane. So here restricted rotation with respect to this one is different, and here this one is different, and this is in plane. So yes, GI. Similarly with respect to this, here oxygen and carbon, and this side, or we can say like this, that here that oxygen and carbon is there, and with respect to this restricted rotation, here hydrogen and lone pair is there. So yes, GI. Similarly here double bond, double bond, double bond, 3 4 5. So 5 double bond means odd, it will show yes, GI. As I discussed, that double bond we can interchange with that ring also, 3 membered, 4 membered, 5 membered, 6 membered, any cyclic ring. So you know one cyclic ring will have degree of unsaturation 1. So here that one double bond replaced with one ring, this double bond is replaced with another ring, this one is third double bond, this one is fourth double bond, fifth one is replaced by another cyclic ring. So same structure only, so both will show GI. Now coming to polyphenyl compound. So polyphenyl compounds, in that two phenyl compounds, you can see this, so it is called poly. So more than two compounds are combining together, so such type of system is poly compound, polyphenyl compound. So in that P and Q and R and S, if it is different, so due to that it will rotate this carbon single bond conformer, so it will not show GI due to free rotation. Or if P and Q and R and S, if it is bulky, so due to that bulky, what will happen? It will have Sir effect, so it will rotate, one phenyl will rotate. So due to that rotation, again R and S is not in plane, so it will not show GI. So for not showing GI in even, what is the reason? When PQ and RS is small or big, it will not show GI. So conclusion is that in polyphenyl, if even number of ring is there, no GI. If it is odd, it will show GI. So like here we can see that this is odd polyphenyl. So due to Sir effect, this will rotate. So this system only will be perpendicular. So now this is in plane and this is in plane. In that we can see here P and Q is different. Here R and S is different. Yes, it will show GI. Now in even number, like here methyl is there and methyl, so it will be perpendicular. So due to that Sir effect, it will not show GI. But here we can see that carbon double bond, carbon, here methyl is there and hydrogen is there. Here also this ring is there and hydrogen is there, means it will show GI. So jab dekho sab dekho, whenever you are seeing, see it completely. Like I discussed in cycloalkene, till 7 member it will not show, but even it is 3 membered, 4 membered double bond system cycloalkene, in that across single bond we can see. Generally we are seeing that even number cannot show GI in that this cumene system or that aspiro system, but in that also we can, even it is seems like even it is even number, in that we can check even odd also. Like here we can see, like here it is like even, so across even it is not, but in even also here this odd we can consider, and through that it will show GI. So whenever such type of questions there, give little extra time like 10 seconds, and then after we understand all those conditions, and accordingly you say that it will show GI or not. Now moving further, after this bicyclo compounds. So bicyclo compounds having very limited concept. Like here you can see decline. So this decline in that total 10 carbon. So with respect to this, here hydrogen and hydrogen is there. So cyclohexane, that a stable form is chair form. So this both chair. So with respect to this restricted rotation, here this and this, and here this hydrogen and this hydrogen. So it is cis. It is cis. With respect to this two hydrogen can be up or down. So it is cis. Whereas here this one is trans. With respect to this, we can see here this one. So here we can see that actually little bit we need to change. Like here this one will be trans, whereas this one will be cis. Like here both sides same, where this one could be different also. So this is trans. Now here we can see that cyclohexane, in this, that this carbon having that two valency, means one this bond and one this bond. So this both bond cannot be together up. If it will be up together is not possible, means it will be like together both cannot exist. So here one will be down and one will be up, or either this will be down, so this will be up, means it is having fixed structure. But if it is this two, that bicyclo system, if it is like this, in that gap is there at least one gap or two gap, three gap, then it will show GI. How? Like this one is up, so this one also up, it can show GI, or one is down, one is up. Now we will discuss like cis and trans is there. So similarly another one representation is there, E and Z. Like cis and trans, in that at least here you can see P and Q. So P and Q is not same, R and S is not same, but at least in this P and Q and R and S, at least one is same. So then only cis and trans. If it is all are different, P, Q, R, S, all four are different, then there we will do by E and Z, integn and jusamine. That naming we will give for that geometrical isomer. So like here we can see that, suppose this is double bond system. So across this fluorine, chlorine, bromine, iodine, or one interchange. So this is. So here we can see that highest atomic number here in this chlorine having, and this side highest atomic number iodine having. So here both are in same side, so it is called jusamine. Whereas here chlorine and this side iodine, so it is opposite, so it is called integn. But does not mean that if Z is there, so it will be cis or trans. It can be changed. So generally we have conceptions that if it is cis, so it will be like, if it is like here cis, so generally it will be like, here we can see that this one is trans. So trans, and according to atomic number, here it is jusamine. So generally trans is considered like integn and cis is considered like jusamine generally, but it is not fixed. Like here it is proved that this one is trans and it is jusamine, whereas here it is cis but it is integn, because here atomic number high and here its atomic number is high, so it is integn. So there is no relation between cis and trans and E and Z. E is what? Integn, higher priority opposite direction, jusamine higher priority in same direction. So three scientists there, Chan, Ingold, Prelong. So they gave one theory, CIP rule. This, all those rules we have to apply in sequence for finding its that geometry name E or Z. So first is that priority directly proportional to atomic number of directly attached atom. Second, if atomic number directly attached atom is same, then we will check its atomic weight of directly attached atom, like in case of isotopes. Third, if directly attached atom is same, then observe next bounded atomic set. If any atom of the set contains higher number, then higher priority. And fourth is, if directly attached, if suppose that directly attached group of atom is containing multiple bonds, then we will create its dummy atom. And fifth one is, when competition is between cis and trans, then cis will be priority. E and Z will be, and in R and S, R will be. So like here we can see here that conjugated, that restricted rotation is there. Now here multiple bonds are there, here also multiple bonds are there. So we need to create its dummy atom. So how to create dummy atom? So here that carbon is there and one hydrogen is there, right? Now it having double bond. So since this carbon is connected to this carbon extra with a double bond, means one carbon you connect here. And similarly this carbon is connected to this carbon. So you connect one carbon here. So carbon, hydrogen, hydrogen. Similarly this carbon having triple bond means this carbon 3 times connected to this carbon, means one already connected to 2 more again connection carbon carbon. And similarly this carbon is connected, so here 2 more carbon. So this is dummy representation. Similarly here also carbon 3 times connected to nitrogen, so one already connected, so 2 more. Similarly nitrogen connected 3 times to carbon, so one already connected, 2 more carbon here. Similarly here carbon oxygen, so one oxygen here one carbon. Now after this, once dummy is done, then after we will see priority. What is the priority? That if first atom is same, then you compare the three set of element, and in that whoever having highest atomic number, that set will be considered as a priority. So like here you can see hydrogen, carbon and carbon, whereas here this carbon having 3 set of element, carbon, carbon and carbon. So here carbon, carbon, carbon means 3 carbon is there, here 2 carbon, so this will be priority, means this will be priority. Now coming here, so here this carbon having nitrogen, 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 whereas this carbon having oxygen, oxygen and hydrogen. So since here oxygen atomic number is more, so this will be priority. So here both are in same side priority, so it will be called Jusamen. Now coming here, in this that this one is trans, whereas this one is cis. So in cis and trans, cis will be given priority, and here this is trans, whereas this one is cis, so cis will be given priority. So same priority, same side, that priority is same side, so it will be Z. Now again always we have to apply rule in sequence. So here that carbon atom is same, and here that multiple double bond, so double bond is there. So again we will create dummy atoms. So here one carbon, here also one carbon, here also carbon and hydrogen, here also carbon and hydrogen. So now on behalf of this we can see this, that so yes, here we can see that here this one we need to add, like here this one methyl was missing, so here methyl. So now here it is E and this one is Z. So in this E and Z, which one? Integrin and Jusamen will be given priority. Here that again dummy we need to create. So as here carbon and hydrogen will come, and here carbon and hydrogen, whereas here hydrogen, hydrogen. So if we'll take its 3 atoms, so it will have hydrogen, hydrogen and carbon, whereas here it having carbon, hydrogen and carbon. So this one will be given priority. So as priority is opposite side, so overall it is integrin. Similarly here coming to this, so 3 membered odd, so this is in plane, so fluorine, chlorine, bromine, iodine. So here chlorine and here iodine, same side, Jusamen. Now calculation of GI. So always understand, whenever that compound is not symmetrical, means no plane of symmetry or center of symmetry, then it will show GI, and that will be always valid 2 to the power n. It is universal. But if compound is symmetry, it having plane of symmetry or center of symmetry, then if it is even, n is even, then total number of GI will be 2 to the power n minus 1 plus 2 to the power n by 2 minus 1. and if it is odd then it will be 2 to the power n minus 1 plus 2 to the power n minus 1 by 2. So n is number of geometrical set. So like here we can see that this one is symmetrical. So if it is symmetrical, so total it will be, whenever it will be not symmetrical, then 2 to the power n. When it will be symmetrical, then odd and even we will see. So n is here odd, so we'll apply this formula, 2 to the power n minus 1 plus 2 to the power n minus this one, n minus 1 by 2. So total 2. So one cis and one trans. Similarly here coming, so you can see that double bond and this double bond, it having symmetricity also. So odd and along with that it is symmetrical. So it is also that 2 to the power n minus 1 plus 2 to the power n by 2 minus 1, total 3. So total 3 are possible. Here if n is equal to 4, so n is equal to 4, so it will be, you can see, unsymmetrical. So direct 2 to the power n 16. Now coming here, this formula is only valid when that system is not having branching. Like here no branching, here no branching, here no branching. But here if suppose this one we are considering as a main chain, so here this is considered as branch. So now we cannot apply this formula. So always we have to do by heat and trial method. So suppose this carbon, so with respect to this carbon, if it is Z, so this will be also Z, Z and Z. Or 3 are Z, 1 will be E. Or 2 are Z and 2 will be E. Or 3 will be E, 1 will be Z. Or 4 will be E. So total how many? 5. Now here we can see that total GI in this. So here restricted rotation, here restricted rotation, here restricted rotation, here restricted rotation, here also restricted rotation. So it will show GI. So total how many? It is unsymmetrical. So total how many geometrical centers are there? 1, 2, here also this 3 in plane, here 3 also in plane, here this one also in plane. So total how many geometrical center? 1, 2, 3, 4 and 5. So 2 to the power 5. Now coming to properties of GI. So here that stability. So generally trans is more stable than cis because of less steric hindrance, because bulky groups will be empty. Whereas sometimes cis also will be more stable than trans when it will have interaction like hydrogen, intra-hydrogen bonding. So trans, here cis is more stable than trans. Now coming to dipole moment. So dipole moment, cis will have more dipole moment than trans if terminal atom or group of atom contains same natures. So like here terminal atom, like here this one is electron donating. Similarly this one also plus I electron donating. So it is mu not equal to 0, it is polar. Whereas coming to trans, if both are cancelling each other, so it will be 0. So here what? When cis will be greater than trans, when terminal atom is same nature. So like here terminal atom, both are donating. But if suppose terminal atom is, one is donating like plus I, whereas one is minus I. So then in that case what it will be? This vector sum will be more as compared to this vector sum. So this one is more polar than this. Melting point, boiling point always directly proportional to mu. So those mu will be higher, their boiling point will be higher. And melting point always directly proportional to packing fraction, means melting point always trans will be more than cis, because in trans packing fraction will be proper, like here one is small, then similarly here one big and a small. Whereas in cis both will be in same side, big and big, so their packing will be not that proper. So due to their melting point will be lower than trans. Now after this we will discuss optical isomer in last part. Thank you very much.